Hello guys, this is Trista. So today, this talk will give the introduction about the database, especially distributed databases on Kubernetes and how to solve such issues. I'm Trista Pan. Now it's the co-founder and the CTO of Sophia EX. Actually, this company, this startup, it's built it from open source project. So it's open source commercial stuff. As my area, it's around the distributed databases and around the cloud databases. Sometimes I will give some the post around the open source, around the Apache Software Foundation, around the distributed databases, all the stuff on my Twitter and LinkedIn. So if you have some questions about today's topic and also want to talk with me more, you can give a look there, my Twitter and my LinkedIn. Yeah, so let's get started. Today, our talk will include the following items. The first one will give the issues because if there are no issue, it's no necessity to give some talks around this solution, around this talk. The next one, we will talk about the Kubernetes and databases and also about the distributed databases architecture. Then, based on all of the background of these knowledges, I can give them the new idea or solution to help you solve how to leverage your existing PostgreSQL or MySQL, such popular open source monolithic databases on the Kubernetes and upgrade them to become a distributed one. Therefore, you can have the such distributed database system can help you solve the, for example, the high availability or you need more performance TPS or QPS, where you want this solution to help you manage the tremendous data stored in your existing PostgreSQL or MySQL. And the last part, if I have time, I will give the demo show to introduce them step by step. But if I have no time, I suggest that you can sign up by this slides by yourself. All right. So the background or issue that our service from the monolithic architecture to become a distributed one, that means the microservice or the serverless architecture, then we will consider to leverage this wonderful open source platform, Kubernetes, to help us to manage the traffic and to manage the microservice, right? And or server, you can see here as the infrastructure. Most of them consider to move our infrastructure from the on-premise to the cloud because the cloud have the best service to help you scale up or scale in, scale out or scale in, scale up or scale down your infrastructure, especially your service server, right? So in the middle layer, that's about your databases, how to deal with your databases. And we will consider the first one, how to make our existing monolithic databases become the distributed one, to make your database system to have the scaling feature, to have a high availability feature, and to let your database system how to manage tremendous, enormous data and also offer you the best performance, right? And especially people will consider, could I put my databases on the Kubernetes to help this wonderful platform to help me manage or the deploy or our DB databases system as same as the service, right? Or application, all of the stateless application or service. However, when we speak of the Kubernetes, actually, it's born for the stateless application or services. It can help us to automating or deployment, scaling, and management for all the containered application. That especially for the stateless applications. How about our databases? Because everyone know the databases is mostly different from the stateless service. We need to consider the data persistence issue and how to manage the status of our replica or primary nodes of our database system. And also we need to consider the backup and restore our data. That means how to backup our data or restore our data to one specific point, right? But however, no matter it's the stateless service or stateful service, actually all of the applications needs the monitor high availability, automatic deployment, and security, or the service quality, all of the features. And that's the shared requirements from our users or from our DevOps, right? But today we will focus on the difference between the stateless services and stateful services, because today we all want to solve is how to put our databases on the Kubernetes. And that means how to make our databases and have the scaling features or automatic deployment or management features. Yeah, traditionally, actually, currently, all of the database vendors, they provide some of the solutions on the Kubernetes. That means put their distributed database on the Kubernetes. And they need to leverage the PVC, and storage class over Kubernetes native mechanism, and use the stateful site to deploy their databases. And also leverage the pod identity of the mechanism to help them to put our distributed databases on the Kubernetes. And I have to say it's a good way to evolve to put our databases on Kubernetes. Therefore, your application now it's are all born or live in the Kubernetes. And if we can put our databases also in the Kubernetes, therefore your application can directly visit your databases in the same Kubernetes. I mean the area or this area for this. This part, right? So but however, actually today I want to give another solution about how to leverage your existing PostgreSQL databases and put them into the Kubernetes. The first solution, like I said before, you can also use some of the like PostgreSQL operators or use the PVC storage classes to help you to deploy all of the databases, all of the stateful applications on the Kubernetes. But today I can give another way to figure out that issue. Let us first look at the distributed databases. Actually, when we speak of the distributed databases system, we will split this system into two parts. The first one, that means your distributed database system, it's made of two parts, two important elements. The first one is computing part. The second one is storage part. For example, I can give them the architecture, the high-level architecture of the MongoDB or CrocodileDB. That's all the popular distributed database system. You can see here they also have their storage part, storage nodes, and also the computing nodes. Computing nodes, it's like the data proxy or the data router. It can help you deal with the request from your application, but all of the shard, all of the storage nodes, they can help to persist your data, right? And it can help you to manage your data part. On the other hand, computing nodes help you deal with the computing part, right? So that's the basic introduction of the distributed database system. So if we can really understand such an architecture, then we can consider how to upgrade your favorite existing PostgreSQL or MySQL databases to make it become a distributed one, because I know that the PostgreSQL or MySQL, they already, have been popular for many years, and people love it, and they already deploy it and manage your existing production environment, right? So can we don't overturn your database infrastructure and just to upgrade to become the distributed one, right? That's another solution for you to solve the distributed database system issue, right? So like you can see here, the first solution for you, if you found that your PostgreSQL cannot help you manage the enormous data, and you found the request from the Postgres becomes slower, and you want to make it have the more performance and the TPS, higher TPS or QPS, you can just remove or get rid of your PostgreSQL database infrastructure and just use the current popular distributed database one, like CorporalDB or other like Aurora databases. But another solution, that the question here, that we can consider continue using the PostgreSQL, MySQL in your production environment. But at this point, you just use all of the PostgreSQL cluster as the storage nodes, storage elements of these distributed databases. And all of the PostgreSQL instance, or we can call them storage nodes, can help you persist your data or do the local computing. And at this point, we can just import or use global computing nodes into this distributed system. Then we can use the PostgreSQL working as the server nodes, and important new global computing nodes work as the database proxy, and to group all of the elements become a distributed one, right? Therefore, we can upgrade your MySQL instance or PostgreSQL instance become a distributed one. So here, the key point is that what's the global computing nodes? Who have the capability to work at the computing nodes? That is Apache Sharing Sophia. I will introduce it later. But now I can give a high-level solution about this. How to leverage your PostgreSQL instance to upgrade them, become a distributed one, and also put these distributed databases on your Kubernetes cluster, right? So as I said, Sharing Sophia can work as the database proxy or the computing nodes of this distributed system, and your PostgreSQL can work or act as the storage nodes and to help you manage your data. And computing nodes can help you deal with the request from your application, right? So therefore, because all of the two parts are independent from each other, so you can put your computing nodes into your Kubernetes cluster, because Apache Sharing Sophia or computing nodes, they are the stateless application, and Kubernetes is born for stateless application, right? So if we can put the computing nodes into your Kubernetes cluster and can exactly fully leverage the Kubernetes mechanism to manage or deploy all of the stateless computing nodes. And here you have two options to deploy or manage your storage nodes. The first one, you can put your storage nodes into your Kubernetes. That means you deploy your storage nodes. That means PostgreSQL database instance into the Kubernetes and just allow the computing nodes to visit your storage nodes and your application just send a request to your computing nodes, right? That's the first option. The second option that I recommend, because you know that Kubernetes currently is not so good to help you manage the stateful databases, right? So you can just leverage the RDS on the cloud, on any cloud, and just deploy Sharding Sophia. That means the computing node of the distributed database system into your Kubernetes cluster. Therefore, your application just send a request to your computing nodes, and your computing nodes will run the global computing work, and then to get or to persist the data into your or from your storage node. That means your RDS. MySQL RDS or Postgres RDS, right? But for your application, they will sync your application just visit a database, a distributed database. Actually, this database is for the application. It's a single one, but for yourself, from the internal perspective, it's made of a two-part, right? But however, you just independently deploy your storage nodes and computing nodes in the different place. The computing nodes live in the Kubernetes, and your RDS were born on your cloud, right? Yeah. So what's the benefits of this my solution? The first one, it can help you leverage your existing databases. You don't want to do the totally change your database infrastructure. The second one, it can help you upgrade it to the distributed one, right? Therefore, it can meet your new requirements for your databases infrastructure. And the next one, because you import Sharding Sophia in your database distributed system, that means this open source project can provide you more grateful features. For example, the data sharding, rewrite splitting, SQL audit, that means the SQL firewall, and elastic scaling and scale out such features, right? And the next one, that it gives you another way to help you put your distributed databases on the Kubernetes cluster, right? Plus, because Sharding Sophia, it provides the operators and provide the Helm charts, so it actually provides your out-of-box deployment way to help you to upgrade all of your database infrastructure, become a distributed one, and make it happen in the Kubernetes cluster. Yeah. So I mentioned many times about this open source project, Apache Sharding Sophia. So what's Apache Sharding Sophia? It's a Apache top-level project, and this project basically it's a database proxy, right? And this database proxy or database engine can help you, like here its introduction, transfer any monolithic databases into a distributed one. And also provide more grateful features like I introduced before, rewrite splitting and auto-scaling scale-out, data sharding, and SQL firewall or SQL audit or logging, all of the grateful features around your databases. And because this project has open sourced for more than 5 or 6 years, so it has a mature community. That means you don't worry that you are the first person to use this project, and many people already help you check this repo and to test this project. And it provide many user cases and the documents to help you quickly set up and use this project. Yeah, so that's the basic introduction about this project. The next one, I will give some the introduction about the features because that's the important part. That's the value of this project. So Apache Sharding Sophia, it has the 2 clients for you to choose. The first one, Sharding Sophia JDBC. It's actually a Java driver for your Java application. When you import Sharding Sophia JDBC into your application, it can help you do the following features or the functions: the data sharding, elastic scale-out, distributed transaction, rewrite splitting, or data encryption or data masking. Actually, because another client is Sharding Sophia proxy. It's a database proxy. So your application, no matter it's the Java or your Golang or the PHP, you can just use some the standard database driver and to visit Sharding Sophia proxy. And Sharding Sophia proxy or Sharding Sophia JDBC for your application, you can just regard it as a distributed database or the server. But the Sharding Sophia proxy or Sharding Sophia JDBC, actually it helps you manage your MySQL, PostgreSQL, Oracle, SQL Server database cluster. That means it's not just to help you manage your database cluster. It can enhance this database cluster to make it become a distributed one and enhance it with a lot of useful database or the features you care around your system. Yeah. So you can see here that's all of the features and of the databases it supports, and it's the deployment architecture for you to choose. So today I will use the Sharding Sophia proxy to help you do this demo show. That means at the beginning, your application just visit your primary PostgreSQL instance or replica PostgreSQL instance. But now your application no need to care too many replica instance or primary instance, right? Just visit Sharding Sophia. There's only single database server. And this database proxy, this database server help you to manage all of your database clusters and to do the rewrite splitting, right? Data sharding, data masking, data SQL audit, all of the grateful features you want to use for your application. Yeah. So so the next part, it's about Sharding Sophia on cloud. That means, so Sharding Sophia is so great, but I want to easily use it and want to deploy this stateless proxy, the computing nodes cluster into your Kubernetes cluster. So Sharding Sophia on cloud is a repo to provide the Helm chart operators to help you automatically scale in, scale out, and deploy this database cluster. Yeah. So So you can see here, you first you need to use Sharding Sophia operator chars to deploy Sharding Sophia proxy into your Kubernetes cluster, and plus you need to pick up the PostgreSQL chars to deploy your PostgreSQL into the Kubernetes. But if you already have your RDS on AWS or on Google, then you no need to use the PostgreSQL char to deploy it into your Kubernetes cluster, right? Like I mentioned before, you can just leverage the RDS server from your database vendor and just deploy your computing nodes of this distributed database system into your Kubernetes cluster, right? And your computing nodes can directly visit your RDS or the databases on the Kubernetes. Anyway, yeah. So today I'll give this solution detailedly, because these slides I introduce how to deploy it. The second one, after you deploy it, you will consider how to create a sharding table, or how to, because you are using when you use Sharding Sophia proxy, actually you are using the distributed database system. That means if you want to create a table, it's not a single table in one PostgreSQL instance. It's a distributed sharding table locating in different PostgreSQL, but for your application, it's just a single one logic database or single one logic table. But this logic table, for example, this one user table, it's made up of 4 subtables or physical tables live in different, here PostgreSQL instance, and each cluster of PostgreSQL has a primary node and a replica nodes, right? So you can see here there are two Postgres cluster. Each one has the one primary node and a replica nodes, and your logical single table, table user for your application, there is only one table. But this T user table, it has 4 physical tables, right? So here we use a distributed SQL, this SQL dialect of Sharding Sophia to help you define this user table. For example, if you just use the create table T order, that means it can help you create a single one table. But you use the distributed SQL, this SQL dialect of Sharding Sophia, it can help you to create a sharding table here. So you can see here we use this keyword sharding table, not just a table, right? So it's very easy for you to get use of this distributed SQL language to help you to manage or define your sharding database system, or this logic, the tables or databases. Yeah, so your app, when you first one you deploy it, second one you create a sharding database and sharding table, then your application just send a request to your computing nodes or this whole database distributed system. For example, this application send the query here, and when your proxy receives this query, it will do the following steps and to calculate which PostgreSQL instance own the result of this query. And Sharding Sophia will send the query to the target, maybe one or maybe many PostgreSQL instance, and to get the local results together. and then calculate the final result or merge the sub result into the final one and send the final result to your application. So that's the basic process of each query. The next part is the demo show. I have no enough time here, but you can see here we just deploy PostgreSQL working as the storage nodes into your Kubernetes. But actually here you can just use your RDS. It's okay. The second one, deploy sharding Sophia proxy, and then to create your sharding table and insert some testing data and to execute the query to test it's okay or not. Yeah. So I already do this demo by myself. You can see here how to deploy it and how to create the databases and the table, and how to let your proxy visit your RDS or your PostgreSQL instance, and then how to define your sharding table here, and then how to insert the testing data and how to execute to test it works well or not. All right, so that's all about today's talk. If you have some questions, you can just ask me here or visit my LinkedIn or GitHub or Twitter. All right, thanks for your time. See you.